Okay, all right. Well, happy Friday, everybody, and hope things are going okay. If you're having trouble getting Git or Python or Jupyter or any of these things set up on your machines, come by office hours. Again, I got them. I'll have them today from 10:30 to 11:30. Come by and I can help you get set up. So that's going on. Okay, so I've posted another lecture to my GitHub. So this is me, the professor. It's under Smiles Chen. There will now be a lecture for 1-3 basic data types. Your forked repository might need to be synchronized, and you can click sync fork on GitHub and do it that way. Okay. And this will pull everything from the upstream repository from mine. So that's nice, and it'll say it's up to date with Smiles Chen. So that's one way to do it. You can click the sync fork button. Likewise, you can go to your on your computer. You got to use cd into your directory there, and then you'll do git pull upstream main. Okay, and when you do that, it will pull all of the things from the upstream repository. Okay, again, this is assuming you have your upstream repository set up, right? And then once you have that, you can check the status, and then if you need to, you can kind of push, and it will get everything all up to date there. Okay, so that is that's Git. So again, once you have your upstream repository set up, you can just kind of pull from the upstream repository to get your local repository up to date. So hopefully I will sell you on how useful Git is as a way to kind of distribute files and whatnot. And so as I update more things or add more files to our repository, you'll be able to pull all of those things just with a couple commands from the terminal there. Okay, well let's go ahead and take a look. And so I have the this time I've opened up the notebook on VS Code, right? And I'll go ahead and I'll clear everything out, and we'll take a look. So today we'll look at some of the kind of basic data types and things that exist in Python. So this will be kind of, now we're just starting to get into the very, very, very basics of programming in Python here. Okay, so we have that. All right, and again, you have multiple ways to kind of run these notebooks. You can from your terminal, you can type in Jupyter Lab, and it will open up Jupyter Lab from your location. So I generally recommend navigating to that folder 2024 fall stats 21, open Jupyter Lab there, and then you can open up the new notebook from within Jupyter Lab, and that's what we did on Wednesday. Or if you have VS Code up and running, you can just kind of open the notebook directly in VS Code as well. Okay, so here in our notebook, I'm just talking about some of the different data types that we have in base Python. There's a whole bunch of these things, and there's going to be other data types that are also really important that that get kind of created after you load up libraries like NumPy and Pandas. But first, we will start off with the data types that exist in base Python. Okay. And so we'll start off with kind of individual values, like these are the data types. String, is this large enough? Do I need to make this bigger for those in the back, or is this okay? Thumbs up? Okay, all right. So we have strings, we have integers, we have floats, booleans, and then there's also the none type, okay, for none, okay? And then there's a bunch of kind of other data structures that are also very important. So we have these kind of sequence data structures, which include lists, tuples, and ranges. We have mappings, dictionaries, which are kind of one of the backbones of Python, okay? And then we have sets, we have bytes, other kinds of things. Okay, so here you can find out the data type, okay, by calling the function type. And so here I have type, quote 2, so what do you think the type is for this data type?
String.
It's going to be a string, right? Okay, so we got to activate our kernel. And so indeed, when you ask, hey, what is the type on quote 2, it comes back and it says that's a string, okay? All right, whereas if I type in just the number 2 by itself, that's going to be an integer. And if you have a 2.0, that's going to be a float, okay? So a key kind of difference between R and Python is that the default numeric type in R is a double or a float, okay? So it's a double precision floating point, or a 64-bit floating point number, and so it will say double. So if you ask like type of on, and you just put in the number 2, it's going to come back and say double. But here in Python, we have 2, which is distinct from 2.0. Okay, we have the Boolean value true, which is spelled capital T, lowercase R-U-E, and that comes back and it says that's a Boolean. And then we have the keyword none, and that's going to be none type, okay? When you ask for the none type there. Okay. All right, math operations. You've got some basic math operations, and it's really kind of a limited set, okay? So you have addition, multiplication, subtraction, division. You have floor division, and you have integer, or the modulo. You also have raising to a power, and you have absolute value. And that's it. That's it for math operations in base Python. Python has the math module, which will expand the kinds of operations you can do. But as far as base Python with no kind of additional modules added, that's it, okay? So here I can take, I'm going to set x is equal to 10, y equal to 5, and first I'm going to ask what is the type of both of these things. Both of these are going to be integers, right? So in Python, if you don't put a decimal value, okay, and if you just type in a number, it's going to see that as an integer. All right, and so if you add two integers together, so I'm going to say z is equal to x plus y, okay, we're going to get 15, and it's going to be the integer 15. Okay, so I could say, what is the type of z? Z is going to be an integer, and z is 15. So no surprises there, okay? If you take integers and you multiply them together, all right, so if I have x is integer 10, y is integer 5, and I multiply them together, x times y, we're going to get z is going to be 50, and that 50 is also going to be an integer, okay? So, so that's what we have there, right? Now, when you do division, however, division will always result in the type float. So even if the result is an integer, you're always going to get a floating type. So if I do 10 divided by 5, I've got the integer 10 divided by the integer 5. I'm going to get the number 2, but it's going to be a floating point 2. Okay, so z is going to be x over y. The type of z is going to be a float. Okay, and one thing that I appreciate about Python is that Python will always display floats with a decimal point, even if it's a whole number. So to let you know that this is not just that this is not the integer 2, but it's a floating point value 2, you're going to always see 2.0, or at the very minimum 2 point, okay, to indicate that it's a floating point number. Okay. If one of your values is a floating point, so if I write x is 10.0, x is going to be a floating point type, okay? Y is an integer, okay? So if I say x is 10.0, y is 5, the type of x is going to be a float, type of y is going to be an integer, and so if you do any kind of multiplication or addition here, the result is always going to be a floating floating point. So x plus y will be 15.0, and then x times y will be 50.0 to indicate that these are, floating point numbers, right? So 10 plus 5 is 15, but it's a floating point, so you're going to get 15.0 and 50.0. Okay. Fair enough. I don't know how familiar you guys are with floating point numbers. So floating point numbers on the computer is not the same thing as real numbers, okay? Because so the computer uses 64 bits to represent decimal values, right? And we often think about this looks like you can represent kind of decimal values, and it can represent decimal values up to around 16 places of precision, but there's a finite number of values, right? So 2 to the 64 is basically the actually less than that, but there's just a finite number of values that you can represent, whereas the real number line has infinitely many values, right? You've got infinitely many values on the real number line. You have infinitely many values between 0 and 1, okay? Or you picked any two locations on the real number line, you have infinitely many values, and we just can't represent infinitely many values on our computer, right? Like if you wanted to store pi, the full number, okay? I don't even know what that means, okay? It won't fit on your computer, right? You could have, 24 terabytes of storage, and that will not be able to contain all of the digits of pi, right? Like I don't even know how many digits of pi we've calculated, but there's infinitely many of them. You won't even be able to store one number on your computer. So, everything is just kind of rounded off to say 16 places-ish, 16 places of precision. And so floating point numbers, there is just a finite number of them. And the largest number it can store is this, 1.7976 whatever times 10 to the 308. So it's a pretty big number. It's just a tiny bit less than 2 to the 1024 power. Okay, it's a pretty big number. But you can't have anything bigger than that. If you do, you get an error. So if I say 2 to the 1023, it says, okay, that number is 8.988 times 10 to the 307, and I can say 2 to the 1023 plus 2 to the 1022 and plus 2 to the 1021, and you get a pretty big number, something times 10 to the 308 power. Okay, but if I try to do 2 to the 1024, okay, we get an error. Okay, results too large. This is an overflow error, and this is that's the limit. It's kind of like I don't know how to make a calculator, but I don't know. Did you ever play around with a calculator as a kid, and then you type in like 9999999, and then you're like plus whatever, and then you get an error, right? Because you only have eight digits on your calculator screen, and you just can't fit anything bigger than 9999999, 8 nines, okay? And so you get basically what a calculator would call an overflow error, and over here you get the same thing, okay? The computer just can't store anything larger, okay? There are some consequences of using floating point numbers. So I don't know if you've seen this, okay? So what is the value of a here? A is 1 plus 2 divided by 10. It's not a trick question, okay? So a is what? 0.3, okay? If I ask what is a, okay? So it looks like a is 0.3, okay, great. Okay, what is b? B is 1/10 plus 2/10. Okay, so what do B should also be like 0.3, okay? But if I ask, is A equal to B, it comes back as false, okay? It comes back as false. And the difference is revealed when you ask the computer to print out 20 decimal places of the number here. Okay, so if you ask the computer to print out how is A being stored, it's stored as 0.2999999998890 or something. Okay, and if you ask how is B being stored, when you do 1 plus 2 divided by 10, okay, you get this. And when you do 1/10 plus 2/10 and you add them together, you get this. You get 0.3000000, whatever, right? So for most people, we would say this is 0.3 and this is 0.3. But as far as the computer goes, these two things aren't exactly the same. Okay, it's kind of like again, think back to an old calculator. Okay, on an old calculator, if you did 10 divided by 3 on your calculator, what would you get? You would get 3.333333, right? Okay, and what if you take that number and you multiply it by 3 on your calculator? You get 9.9999999. Is that the same thing as 10? Okay, from the calculator's perspective, those are different numbers, right? Although, you know, in our heads, we know 10 divided by 3 times 3 should be 10. But for the calculator, when you do 10 divided by 3, you get 3.3333. And when you multiply it by 3, you get 9.999, which is different from 10. And that's basically kind of what's happening internally, except just in binary, of what's going on here, okay? When you do 3 divided by 10, you're getting some kind of number, which is not exactly the same thing as 1 divided by 10 plus 2 divided by 10. Even though in real numbers, these are exactly the same, and the computer, internally, when you store them with a limited number of precision, you don't get, you get slightly wonky things, okay? And so, so anyway, that is something that you have to be aware of when you're doing math on the computer. Sometimes, you might want to do some kind of operation and you're waiting for two things to be equal, right? You say, hey, run this thing until this thing becomes equal. And then the answer is, if you wait for it to become exactly equal, for two numbers to be exactly equal to each other, it just might not ever happen, okay? Because it might actually be impossible to represent some numeric quantity exactly on the computer. So that's something to be aware of, okay? And there is a function called isClose, okay? And so you can load the math library, and you can do math.isClose, is A close to B, all right? And it'll say, yeah, this number 2.29999 and 0.3000, those are pretty close to each other. So maybe you can treat them like they are the same, but they're not. Okay. Integers. Integers in Python, and this is not universal across all languages. So the way Python handles floating point numbers is pretty universal across all computer languages. So whether you're dealing with C or R, these kind of weird things that happen with 0.1 and 0.2 and things being added together, those kinds of things are kind of universal across all computer languages. However, the way Python handles integers is a little bit different. Integers use variable amounts of memory, and so you can store really big numbers, okay? So I do 2 times 10 to the 23, and it prints out the entire number, okay? So, when I did floating point, and I asked what is 2 times 10 to the 23, I got 8.988465, but then it ends after around 16 decimal places, okay? Here, if I say, hey, what is 2 to the 1023, I actually get the full number, 8988465, and it gives me all the whole number, okay? It's really big. Okay, I could ask what is 2 to the 1024, and remember with floating point this blew up. Okay, but here it works fine. It takes a moment for my computer to calculate it. I can ask what's 2 to the 1025, and it does it. Okay, it's got no problem. It can do it. So that's kind of a neat thing about integers here. Okay, let me give you your first view quiz answer. Week 1, Friday. First answer is B.
Is the quiz supposed to be due right after class?
Yeah, the due is, but there's no penalty if it's late.
Oh.
Okay? But it'll just kind of, I guess, distinguish between those who completed it in class versus those who watched it later. But there's no penalty. You'll still get, if you answered all the questions correctly, you'll get all the points.
What was the first?
B. B as in bear. B. Okay? All right. So we have a power operator, star star. So 9 star star 2 is 9 squared, 81. Okay? And the result of the power operator could be a float or an integer. If you do an integer raised to an integer power, the result will be an integer, but pretty much other things will result in a float. Okay? There's no square root function in base Python. So if you ask, hey, what's the square root of this? It's going to say, I don't know what a square root is. Okay? Square root's not defined. But you can do raised to the half power, okay, which is similar, okay? So if you do 9 to raised to the half power, you'll get 3.0, and that's fine, okay? And again, in base Python, you have just a limited array of things, and certain numbers that, or certain functions and values just aren't divided. So if you ask, hey, what's pi? Base Python doesn't know what that is. If you ask what's e raised to something, like the exponent function, that's not defined. There's no trig function, so you can't ask what's the sign of this, right? So if you want to do any of those things, you have to import the math module. Okay, so you just call import math, right? And so this math is a module that comes installed with base Python, and so you just expand Python by calling import math, and then you can do this. And you might wonder, like, hey, why doesn't Python just load up the math module automatically, right? At its core, the philosophy behind Python is that it is what we call lazy, all right? In that it's going to try not to use your computer resources if it doesn't need to. So there's going to be a lot of cases where, you're going to do some stuff in Python, and you don't need to have all of these math. You don't need the math functions. All right, and so basically, it's just not going to bother loading them in your memory and use up your computer's resources if it doesn't need to. But if you need to, they're on hand. You just say, "Hey, import math. Hey, I actually want to use these things." Okay, and then now you have math.square-root, math.pi, math.exponent, math.sine. All of these things are there. Okay, and so that's how you do that. Okay. Regarding homeworks and whatnot, I'm not super strict about like limiting you to a certain set of functions. Okay, so you took Stats 20, right? And I think in Stats 20, the class philosophy for Stats 20 is that it is seen as kind of your first programming class. And it's also a problem-solving class, okay? And the idea with problem-solving is the idea of, okay, if these are the tools you have, can you still solve the problem, okay? So, if you just have, a hammer and pliers, can you still build this thing, okay? And of course, there might be some other tool out there, right? There might be like a jigsaw or something that you can kind of do. But the question is, with just these limited tools, can you still do this, right? And so that's the kind of the teaching philosophy of Stats 20 is often that it's trying to teach you some of these problem-solving skills. Okay, this class Stats 21 is kind of like, okay, well, I'm assuming you gained some problem-solving skills, and now I'm just kind of teaching you Python and how you do stuff in Python, and Python is this, in my opinion, this beautiful and elegant language where you have a whole bunch of kind of features that really make your life nice and easy. And so I am not opposed to you using functions and things that I haven't covered in class. The one restriction is that if I haven't covered a certain like module or library, please don't import modules or library that I haven't covered in class yet, okay? Because Python is so kind of extendable and things like that. Eventually, you can just kind of do like, import like AI, all right? And then you just do like AI.ChatGPT, and then you put in the query, and then it basically, sets up a connection and gets you your things. To that end, like Python is also like super, super fun, because you can start playing around with these really exciting things with just like 3 lines of code. Import this module, and then, here's my API key, and then let's start talking to ChatGPT. Let's start using, Google Maps and things like that. And so there's it's very extensible, and you just have to import all of these modules. But as far as this class goes, I'm going to just ask, don't import modules that I haven't covered in lecture. But as far as like, can I use this function even if this function wasn't mentioned? And the answer is going to be yes. Okay? So if it's a function that exists basically in base Python, the answer is yes, you can use it. Right? And an important thing I want you guys to learn, all right, and that I can't directly teach you in class either, is being able to read documentation. Okay? So, because eventually in the future, you're going to have to use a function that nobody has taught you, and you're going to have to read the documentation and figure out how to learn it. Okay? And actually, to that end, ChatGPT is really great, because you can ask, hey, I want to use this function. Can you give me examples of how to use this function? And it's pretty good. And a lot of its answers is based off of the documentation. And so to that end, I think these AI tools are helpful in teaching you or showing you how to use new functions and things like that. But anyway, that's something you've got to kind of learn, is like you ask help on this thing. Okay. All right, let's talk about Booleans, okay? Booleans are basically true and false, spelled capital T-R-U-E and spelled capital F, lowercase a-l-s-e. So when you ask type on true, that's that. If you put it in quotes, that's going to be a string, so that's not going to be the case. If you spell true or false any other way, so in R, we spell true as all caps true. If you try to do that in Python, it's going to say, I don't know what you're talking about, okay? There's only one accepted spelling for true and one accepted spelling for false. You create quotes or strings by using quotes, and you can use either the double quote mark or the single quote mark. Both of these things will be strings. Okay. Strings are what are called iterables, and so kind of all iterables, you can apply a few functions. One of them is the length. And so as far as the string goes, the length will tell you how many characters are in it, okay? And then you can also do like multiplication and addition with iterables, and multiplication with the iterable, and if that iterable is a string, it's basically just going to replicate it. So if you do 4 times this, right, you get that, okay? Fine, okay? As far as strings go, one of a handy function is called the dot format function. Okay, and so this is actually a method, a string method, and you can use this to kind of fill in placeholders. So within a string, if the string contains these curly braces, okay, the default behavior is to treat those curly braces as like blanks, like fill in the blank. Okay, so it's kind of like so here I'm going to create a variable, and this is going to contain name is equal to Miles. All right, and so here the string I'm writing is my name is, and then basically curly brace name. So I'm putting in a blank here, and my school is, and then we're creating another blank. Okay, and then I take that string and I call dot format. And then I say, hey, fill in the name blank with the variable name, which will be Miles, and then fill in the school blank, this time with the string UCLA. Okay, and so now that prints it out here. Okay, and then if you wanted to, you could change this to something else, right? My name is Joe, and my school is whatever, right? But here, you can put in either a variable or whatever else you want to do, right? So this is strings with curly braces. The things in the curly braces are treated as kind of fill in the blanks there. Okay? And you can learn more about that by reading up on the string format operator. Okay, in Python, we will often assign values to variables, okay? And the way that works, okay, the name of the variable is always on the left hand of the equal sign, okay? And the value that you want to assign is on the right hand of the equal sign, okay? When you assign something, Python just does it. It's not going to output anything to the screen. It's not going to say like, okay, I assigned the value 5 to n. It's just gonna do it, okay? And so it says, okay, I did that. But then later you can ask, hey, what is the value of n? Okay, and it comes back and it says the value of n is this. One thing is that the way Python handles variables is that they are pointers. Okay, so in contrast to other languages like C or Java, when you define a variable, you're creating basically a container or a bucket, okay? So you're gonna say, I'm gonna create this bucket called X, and it's gonna store integers, and into that bucket, we wanna put in the value 4 or something like that, okay? In Python, it's a little bit different, okay? We write just something like X is equal to 4, and then basically that value 4 is created somewhere in memory. And then Python takes this name X and it binds that name X to the value 4 in memory, and then and that name kind of just points to that thing, all right? And then and we can just kind of change what X points to on the fly, and Python doesn't care. It is what we would say is dynamically typed. It just allows you to just kind of change these things. If you tried to do something like this in C, you'd run into problems because it'd say, all right, I was only really meant to store integers, and now you're trying to store other stuff into X, and I don't like that. Python's just like, sure, X is 1, okay, no problem. X is hello, okay, you got it. X is a list, 1, 2, 3, okay, you got it, all right? And so here it just runs this, and then it runs the next line, and it runs the next line. So now X is going to be pointing to this list 1, 2, 3. The other stuff eventually gets lost and thrown out in the garbage collector. So Python kind of also has automatic memory management. So in other languages, in C or something, it's like once you get rid of, once you stop using something, you have to kind of get rid of those variables in memory. Otherwise, the amount of stuff that gets stored in memory keeps growing and growing and growing and growing. And in Python, it's kind of just like, is anything looking at this thing anymore? And if it recognizes that nothing is referring to it, it clears it out of memory. And so there's basically some memory management. You got this thing called the garbage collector, and it does that. And it's all automatic. It just happens in the background. You don't have to think about it. You don't have to worry about it. The cost is that if you're looking for top-notch performance and speed, Python's not it, okay? There's kind of an old joke. Python is the second best language at everything, and it's kind of true, right? It's really good at all kinds of stuff. Is there another language or something that's better suited? Maybe, but it's very versatile, very popular, very, very easy to kind of code up. I would say it's probably the best as far as like if you have a simple idea that you want to implement quickly, you can get that up and running right away. Okay, so when we name variables, you can choose almost anything to be a variable name. There's a few rules, okay? So names, you can have letters, numbers, underscore characters. Your name must not start with a number, okay? You don't want to have any symbols other than, you can't have any symbols other than underscore, no spaces, and it cannot be a keyword. Python keyword. And so these are the Python keywords that are used for kind of flow control and things like that. But other than that, you can name your variables. Now, obviously, you don't want to name your variables to things that are confusing, right? So you don't want to create a variable. So this is the keyword, capital T, lowercase RUE for true. And you could, if you wanted to, create a variable that's all caps true, okay? But that would be a terrible idea, okay? Because that would just be very confusing. So don't do that, okay? So obviously, there's some rules about that, okay? Okay, let me give you your second answer. Second answer, view quiz answer is A. A is an apple. A is your second view quiz answer. Okay, so yeah, the keywords, so the false, none, and true, those are the only ones with capital letters. Everything else is kind of lowercase, and these are things like, you know, your if and your and or, and you know, while and for and things like that, things that kind of create your loops and stuff like that. Okay, as far as naming your variables, there's another programming joke is that naming, you know, there's only kind of two hard things in programming, and one of them is like naming variables. I don't remember what the joke was, but anyway, naming variables, it's tough to come up with good names, okay? And throughout my lectures and my notebooks, I often use terrible variable names, right? Like if you just use the variable name X, it's not going to be helpful, right? Because later on you're going to wonder, like, what does this thing represent? And an X is like not a very, very useful name, okay? You know, the goal is that in the future, you're probably going to have to read some of the code that you wrote, okay? And you're hoping to be able to read your own code and not have to kind of refer back to every single other line in the code to try to figure out what it is that you're doing. And so having good variable names is going to be one of the kind of tools that you will have so that you can kind of understand your code easily, okay? So some of the principles as far as naming variables is you want your variable names to be clear and concise, okay? Your variable names should be written in English, all right? And this is just kind of the de facto is that you know, we program in English, okay? And then you don't want to put special characters in your variable name. So it is possible to kind of use like here I've got A with a double dot over it and O with a double dot over it. That is, I think, technically possible as a variable name. But just the general rule is stick to the ASCII keyboard. So think about you know, your US keyboard, and basically, you know, your 26 letters, or I guess 52 characters, lowercase and capital, and along with the digits 0 through 9 in your variable names, and you don't really want to go beyond that. Okay. You can have variable names. These are not really great because they're not very descriptive. All right, so we have S is equal to 101,533, or SID or SID equal to 101,533, and I think later on it could be confusing. Like, okay, what does S represent? Okay, another variable name that is not going to be helpful is something that is like way too long. So this says Finnish Meteorological Institute Observation Station Identification Number 101,533. So this will help you know exactly what we're talking about, but it's going to be too much of a pain to try to type out every time. Now, one thing is that you do have tab completion, okay? So this is, you can start in Jupyter VS Code. If you start typing out the name of a variable name, this little kind of dynamic pop-up will show up, and you can kind of use your arrow keys to select it, but you can also just hit Tab, and it will automatically kind of complete the rest of your the variable name. Okay, and so you can get that and do that. So that that is one thing that helps, but also you just don't want to have a variable name that's hard to read like that. Okay, so so a few things. Well, one, to make the variable name even easier to read is if you have a variable name that has multiple words, the convention is you can use what's called snake case or camel case. Okay, snake case uses underscores to separate words. Okay, so you have snake case. Sometimes it's called pothole case, right? And basically you use underscores to separate out your words. And then camel case uses capital letters. You have no spaces or underscores, but you use capital letters to separate out the words, right? So you have lower camel case, upper camel case. The difference between lower and upper camel case is that the first character in lower camel case is lowercase, and the first character over here is capital, and that's what you have there, okay? So perhaps a better way to name it would be FMI station ID or FMI station ID here, either with, this would be snake case or this would be camel case. And these would be probably better ways to name your variables, okay? When you kind of name data structures that will contain other things or things like that, there's a few kind of conventions that will be helpful, okay? One is that if you are creating, naming, say, a list or an array, okay, that's going to contain multiple things, the name of that array should be plural to indicate that it's going to contain multiples, okay? So here I have a list with apple, banana, and orange, okay? So not a great name would be just to call this list fruit, okay? A slightly better name would be fruits, okay? By having it plural, just by coming across the name fruits in the future, there's kind of an implication that there are more than one thing here, okay? So again, just imagine, just imagine going to the garage, okay? And there's different boxes, okay, along shelves. And you have labels on these boxes, okay? What is a good way to label these boxes, okay? What would you do that, right? And if you see a box and it says fruit in there, okay, you might expect there's only just like kind of one thing in there, okay? Versus if you see a box and it's labeled fruits, you go, okay, well, that should contain more than one thing. And again, if you just have a box and it has the letter X on it, or one letter S on it, it's hard to kind of figure out what is the contents of that box. And that's basically the problem here, is that, okay, if you're going to come back to the garage and you see these boxes and they have different labels, how can you make it so it's easier to see what's inside each of those boxes, right? A lot of times the storage solution today is, they sell clear boxes at the store, so you can actually kind of see what's inside. But we don't have that luxury so much here. I mean, I guess you do have with VS Code, you can click this variables button and you can kind of see all of the variables that exist, which is nice. But if that's not there, it's not as easy. Okay. Even better than fruits would be called, fruit names, all right? Because that implies the fact that you have names as part of the name of the thing implies that there's the usage of strings inside the list, and so we have that, okay? If your variable is going to contain Boolean values like true or false, it is recommended that your name is phrased as, or your variable name is phrased kind of like a yes or no question, okay? So rather than calling these things select, right, or fruit, okay, better names would be is selected true, okay? can write, true or false, okay? Has fruit, true or false, right? So these are kind of phrased almost like yes or no questions, and that would kind of indicate or give a clue to you that the type of this variable is going to be a Boolean. So if you see the name, variable name is selected, that can be useful. And then later, if you want to create like an if statement, okay, you can just do if is selected, okay? And if it's true, then it will run, and if it's not, it won't, right? And it's don't do this, right? If is selected equals true, okay? This is silly, okay? If it's true, it's going to be selected, and if it's false, it's not. You don't need to do if is selected equals true. Just if it's selected, go forward. If not, okay. If you have something like rows, okay, rows equals 3, not super helpful, okay. Put in a descriptive word to make it a little bit better. So you can say like minimum rows, maximum rows, total rows, current row. These are all going to be much more helpful, much more useful, much more descriptive to help you understand what exactly is being represented by this quantity, rows here, okay? Similarly, we have philosophies regarding naming of functions, okay? And so functions are basically the verbs that we can do, the different actions that we can do in Python. And so if a function is going to modify an object, you want to use like an action verb, okay? So like if this function is going to take something and sort it, you'll call it sort, okay? On the other hand, there are other functions that don't actually modify anything. They give you back kind of like a modified version of that object, but it doesn't actually modify the original object, okay? And so you might use kind of the passive form of the verb. So here, in Python, you have both the function sort and sorted, okay? Sort and sorted. And these kind of reflect some of the naming philosophies and naming suggestions of the Python language. And so here, I have car brand names. This is a list, and I've just got different brand names of car manufacturers: Ford, BMW, Volvo, and Toyota. And there's this function called .sort, okay? This is a method, and this will actually modify the list itself. So if I do car brand names and I call car brand names.sort, it's going to modify this list, and it has sorted it into BMW, Ford, Toyota, Volvo. It sorts it into alphabetical order, okay? Here I've got another list, car brand names, okay? And then I have another function, sorted, okay? And what this does is it doesn't actually modify the original thing. So if I ask, hey, what is car brand names? It is still in the original order: Chevy, Chevrolet, Audi, Honda, okay? Whereas sorted here gives me back a sorted version of the list, but it doesn't actually modify the list, okay? So there's a little bit of, it's a subtle difference, but that's going to be the difference between these two things, okay? So one is actually changing the list, okay, and that's going to be the sort method, whereas this function sorted doesn't actually change it, but just gives you back a sorted copy of the thing. All right, so that's what you have. So again, you can kind of check and see, hey, has it actually been modified? It doesn't. All right, and then if you try to do a couple things, the standalone function and then the what we call the attribute or the method for this thing actually doesn't exist, but these reflect a little bit of kind of the naming philosophy that exists in Python. And so the Python-based language is actually, a lot of thought has been put into how things should be named, how things should be operated. There's kind of this committee, and then they release what they call PEPs for what their proposals and for how they're going to improve the language. And a lot of kind of thought goes into that. And so you can actually learn a lot about Python by looking at kind of the code and the things that already exist and just reading through the documentation. So anyway, so we will wrap up here for today, and then let me give you your last view quiz answer.